So before the break, I was telling you guys the resistance of buckling is dependent on I and LE. Okay, and not just LE. And the LE is affected by the condition of its ends. Okay, so it's best to do this by looking at planes. Okay, before I go any further, we know that the rope, okay, the rope, you all can see the rope, right? Can only withstand applied force on the centroid, which is similar to truss members. Okay. So what do I mean by that? You can see this rope. Okay, so if we were to look at the exact plane. Okay, and we know that the structure. Okay, let me look at the exact plane. Okay, let's look at the exact plane. Then you have rotation about y, right? So we are going to analyze the XZ plane. If we were to look at the rope now, right? So this is our structure, right? And then we have a hidden feature down here, right? And the rope, I'm going to change the color for the rope to red, is in tension in this direction. They're pulling it down. Okay. Right? So the rope can only withstand load along the axis. So we call this applied force. Okay. We call this an applied force. Okay. And the question did say the applied force, right? The applied force is such that the BC and BD are taut. Okay. So this load P should not be affected by the rope. Okay. But what the rope does is the rope have two components of forces. Okay. So over here, you can see that the rope has one direction over here, right? Imposed or the resultant of the rope. Okay, I'm going to sketch the resultant of the rope. The resultant of the rope is acting in this direction from the rope. Okay, so these are our resultant, right? And then we have a force over here, which is P. Okay, P is the one that we want to determine. So when that's the case, right, this rope have a force in both Rx and Rz, and it will go the opposite, Rx and Rz. Okay. So when that's the case, right, we know that when at the top, when the rope is like this, right, or when you have two resistance force, we know that the X motion is equal to what? 0. When when there is no motion, in order to prevent any motion, you must have what? Forces. Okay. So Rx is inducing X is equal to 0. Likewise, Y is equal to 0 is because Rz is inducing Z Z is equal to 0. Sorry, I wrote the wrong thing. However, at the top end, what we realize is what? The moment about y is equal to 0, right? So at the top, okay, so we look at the condition. Okay, we look at this condition. Okay, we look at sorry, I don't think yeah, I don't think the force y will be equal to 0 for this case. Okay, so z will not be equal to 0 because your applied force is in what? Z. But no, the more important thing is the what? The moment about y is equal to 0. So when you look at this diagram over here, right, we know that one end is fixed, the other end is what? The other end, the moment is equal to 0. It cannot move in the x direction, but it can move in the y direction. So therefore, LE is equal to L. Okay, so I'm going to copy this and paste down here. All right. So this is the same as what you have over here. Right? This is what you have over here. So when that's the case, right, what we look at is LE is equal to 0.7 L. Okay, LE is equal to what? 0.7 L. Okay, so the other end, we know that this is fixed. Y is fixed. Moment about y is not equal to 0. X is equal to 0. Z is also equal to what? 0. Okay, so that gives us this condition over here. Then you ask me, Eugene, how will this structure buckle, right? So this thing will buckle, it will debuckle, it will buckle. I want you to see how I sketch how it buckle, okay? It will buckle in this direction. Okay, that's the curvature of the, this is not very clear. I'm going to use a different color. Okay, it will buckle in this direction. And this curvature over here and this curvature are the same curvature, yes or no, about the same axis. So when that's the case, when you write down your force, so P critical is equal to pi squared E. So the curvature is the same as Ry, so it's going to be rotating about the second moment about the y axis, divide by Le. Okay, and that's it. Okay, so this is what you have to do. Okay, so let me highlight again. The rope, right? This thing is important. The rope can only withstand applied force on the what? Centroid with similar to a truss member. So it can the resultant is this direction over here, parallel to the rope. And when that's the case, you can break them down into two components. Okay, so the Rx, because you have two side pulling, it will prevent the rope from going left or the structure from going left and right. So this is similar to what we call as a pin end. Why is it pin? Because moment about y is equal to 0. At the other end, it's fixed because moment about y is equal to 0. Right, as you can see now. In fact, I drew this wrongly. If I'm going to draw this properly, it should look like this. Because at fixed, theta is equal to what? 0. Exactly the same like this over here. Okay, so the end is fixed. Okay, so now once we have all this information, we know that our P critical we calculated is equal to what? P critical is equal to 33 times 10 to the power 3. And then this will be equal to pi squared. Young's modulus given to us is, if I'm not wrong, 29 times 10 to the power 6. Then you have, now we know it's IYY. Okay, so YY is 11.4. And then LE is equal to 0.7 L. So therefore, L will be equal to pi squared, 29 times 10 to the power 6, 11.4 divided by 33 times 10 to the power 3, and then divided by 0.7. So this will be equal to shift pi squared times 29 power 6 times 11.4 divided by 33 power 3 divided by 0.7. So it's equal to, I got a funny number. Wait, shift pi. Wait, the formula that I'm going to use. I forget the squared down here. I beg your pardon. Okay, so if there's a squared down there, I need to put over here. This whole thing is a squared. So when this whole thing is a squared, this thing will be a square root, and then L will be equal to 1 divided by 0.7. Okay. So squared times by 29 power 6 times 11.4 divided by 3 power 3 square root divided by 0.7 is equal to 449.2 inches. Okay. So this is buckling about the exact plane. Okay. So what's so unique, or what is the characteristic about the exact plane, is that we realize that the second moment of area is IYY. So I think a good thing to remember is this, okay, which will, so if the plane you analyze is the XZ plane, right, the second of moment of area is neither X or is neither Z, but is what? YY. Are we clear? Okay, so you don't get you don't get lost, because in a test, I will test you this, whether you know which second moment of area to use and can you identify the boundary conditions. Okay, right. Next, we go for the next plane. Okay, so the next plane that we're going to do, right? The next plane that we're going to analyze, we're going to analyze the YZ plane. So immediately you know that we're going to analyze the YZ plane. So now the P critical is equal to pi squared E I what? IXX, right? Like what I told you before. So this will be equal to divide by LE what? Squared. Okay. So now let's now sketch the structure. So this is our Y, and this is our Z, and then we have rotation about X. Okay, so now our structure will look like this. Right? And then one end is built, and then we have got a load P coming down. Right? We got a load P coming down. And now we know that there is a force. This is due to the what? This is due to the rope. Okay. Oh, I'll write a different color. So we know that there's a the rope now is applied. This force is due to the rope. Right? So what we realize over here is moment. Okay, what we have realized over here, moment about X is equal to 0. right? However, one thing is interesting now. We know y is not equal to 0, right? Because it can come down due to the load P, right? And we also know x is not equal to 0 because there's no resistance force, okay? There's no applied force in the what? In the y direction. Sorry, I got it wrong. Okay, what I got it wrong is here. We know that y is not equal to 0 and z is also not equal to 0 because it can be pulled down, right, due to the applied force. So the only condition where y and z is not equal to 0 and moment of z is equal to 0 is where this is what? This is free. Why is that? Okay, so if we were to go in